I am recording now. Okay, so we're going to be doing an AI ray movement implementation. So the essential idea is to actually have a script attached to a game object. And this game object, when that script is attached, will actually just move on its own accord. So it's a basic idea of AI movement here. Except I don't know where the guy is. Is he invisible? Should be here somewhere. Unless I'm looking at the scene here. Okay. Not over here, is he? Well, let me go back. So we're not gonna click on this, and we're just gonna start the game, right? So this object here should move on its own accord, and it is, right? So what we're seeing here is the script doing its magic here, which is having an AI basically, if it gets too close to a wall, it kind of horizontally tilts based on some angle. And it's just some random angle. But if it gets too close to me, it does the same thing. And when we shoot it, it just falls to the ground. And you kind of see that it's not moving anymore. And that's like a little subtle detail there. So to actually explain the essential idea, what we're going to be doing is having an AI move on its own accord. And it's going to be given to an object, game object. Just imagine this guy to be John once again. So to actually implement this, and I have these two scripts here. They're just reference, but it's better if we kind of just walk through it, right? So we could say AI movement, and when we consider AI movement, it's just going to have this specific object translate along space here. So we know that when it comes to movement, we need a type of speed. So we could make a float here. We could say public float speed. Let's say it moves at this speed, right? And we're going to do what's this range here. So the range is just specifically for, like, if the object gets too close to a wall, then the object's going to turn. But right now, this is going to be used as a condition for some conditional statement. But right now, we're just going to have this to be the way it is. So we're going to have this object, right? Translate. Actually, I think it's transform. Transform. Wait, hold on. Okay. So we're going to have this AI move, right? To actually do that, transform. You're going to say a translation. And we're just going to say for now that we just have these as 0, right? So X is to move left or right. Y here within the translation method is just to move up or down. X is to actually move forward and backward. So that's what we want. We want this specific AI to move forward or backward. And we're going to reference time here, delta time, so it can have it actually be frame independent. So, based off the speed of the computer, it's actually working accordingly to it rather than some other variable. So now what we're going to do here is actually make a ray here. So the same way you kind of shoot at other objects in space, like I just did earlier, that was a thin line ray. We can have specific rays in which are just spherical. And these rays are used in the context of actually having an AI move forward as well, based off of the direction it's actually looking at. So to actually have this be the case, we're gonna say new ray, right? Oops, new ray, and what we're gonna pass down is, oops. So we're gonna say transform, right? The ray is gonna be at its origin point. So we're just gonna say game object position here. Actually, I think it just refers to itself. Yeah, okay. Okay, transform, and we're gonna say forward here. So what we can expect is, this is the object, right? The 0. Whoops. And the ray is gonna be going this way from forward of where the object it's looking at to maybe some wall or something, right? That's what we could expect. To raycast, it is just so we can actually keep track of the information of the ray itself. So we're going to make this if statement, and we're going to say physics. We're going to say sphere cast. Instead of raycast, we're going to do sphere cast. So what we're going to pass down here is the ray itself. And we're going to define the radius in the middle here. So the difference between range and radius, just in case if there is some mix-up, is that the range is a measurement of how close the object is to a wall, while the radius is just kind of the range, or not, it's the radius around the object itself. The ground below the object defines which direction it could tilt. So you can kind of think of it as like having like a clock under you. I know that's probably not the best analogy, but just imagine, right? The clock hands and they're turning in some direction. And if we want this object to actually move in that specific direction, then the clock hand has to move at a specific angle. And this is going to be based off of a horizontal tilt of a rotational method. And, it doesn't sound concrete, but I'll show what that means. So we're going to do this. And first, we're going to say, excuse me. Oh, I got clear my throat. Okay. So we're going to say this. So if the game object position, right? You can say range. What am I saying here? So actually, oh yeah, hit distance. So hit distance is going to be based off of uh, the distance away from uh, the ray and the game object, right? So we know that when the ray, let's just imagine this again as like the game object, right? And the ray is kind of going, it's pointing to some wall, right? So the distance might be, for example, maybe like 7 point whatever, right? So that's what hit distance means. It's just the distance between the game object and the static object. So the reason why we want this is because now we're going to use our range conditional here. So when this happens, we're going to say this. We're going to say that, okay, the game object or the AI itself is moving a little too close to that wall. So what we want to do here is have that object actually rotate a specific angle. So we're going to say this, right? We're going to say float angle, and we're going to reference the random class. So the reason why we want to reference the random class here is because we want to define an angle between 110, or negative 110 and 110. So it actually, moves at a specific angle or turns around. We want this AI to just turn around horizontally. Or yeah. So to explain here, because rotation is still a little confusing for me, but we're just doing this. So this right here and that. Oh, there we go. What am I missing? That's good. Let's get delete that. Okay, never mind. What's this for? update for the if statement. Okay. So now the object it's gonna horizontally to. So now that we have that, right? Now we have some type of movement action going on. So let's actually see if I actually did do it correctly, and if I didn't, I'll just go back to it. So I'm just gonna go back here, and we're just gonna attach this script here. First, let me actually click on the game object itself. So this here, I'm gonna put that there. So this script here, this was from a previous instance, but let's actually now look at the object itself. So let's see here. So we can see it now, moving, right? So this object right here is going to be moving, but let's just let it, dilly-dally, let it just have its own agency for a little while. Then we're just going to shoot at its back. You see that? We don't want that to happen. So this is where we actually keep track of the state in which it is alive. So now we have to kind of go back here. So the intention here is to kind of assume that this object has a type of Boolean, right? A state in which captures whether it's alive or not. So we're going to make a variable here. We're going to say private Boolean alive. We're just going to say this, right? So when this object is, starting up, we want this to be alive, right? So we want all these lines to only execute if the object is alive, right? Actually, let me see here. So if the object indeed is alive, then what we just saw earlier of it moving and such, just moving, right? But what if it actually, dies, right? So what we're going to do here is make a new method. We're going to call this method. This method here is going to keep track of the state of this object itself. So again, we just say is alive. And it's going to take in a Boolean value. And we just call this alive. So we say live. And this is in reference to this private Boolean variable, right? So it's still true, right? If this object indeed is alive, then all these lines will execute respectively. But on the chance that this method is called somewhere else, then what we have to do is pass down a false so we can actually ensure that the object isn't alive and that what's happening within the update method of AI movement is stopped. It's like flipping a switch, right? If the object is not alive, then we turn the switch off for its movement because we don't want to see what happened with that object, right? And it ascending to the heavens. So this is good for now. So we're just keeping a track of whether this game object is alive. So we're going to use now the entity script here. And this was based on previous videos. These videos I've been making, they kind of just they're built on top of each other. So what we're going to do here is within the react to hit method. I don't know why I said that with such venom, but so right here, right? The react to hit, this is only used or called when the entity actually does get hit, right? Well, obviously, but still. Now, the react to hit, it's only called based on condition. And it's called based off of aim right here. So I know I'm explaining something I don't need to, but just in case if there's no prior knowledge of what the heck is going on here. What we have here is an aim ray, and this aim ray extends from the player onto, either just a static wall or, like let's imagine now this is the player, right? One. And we say, it's a ray and it hits John, right? So John should actually just get hit and actually call the method respectively, which shows that John falls into the ground. So like, right here, ray cast, ray out hit, right? Entity John. So this ray here, it's going to extract the information of whether the object in which it did hit was John, right? So it says entity John hit object get component. This will be null if the player actually just hits a wall. So if the player hits a wall, then it's just going to be null. So we're just going to start the coroutine and has a sphere indicator, which creates a sphere at just at that wall. But on the chance it does hit John, then this is going to be called. And when that's called, we should flick the switch for this movement here because we don't want John to ascend to the heavens. So what we just have to do here, we don't have to do an if statement because this is already kind of a conditional method in itself. So we just say this. We say AI movement, right? We want to reference AI movement. And we'll just say AI. And we're going to say a get component. Just going to call it AI movement. So the same idea applies here, right? We want to see whether this is null or not. And it's not going to be null because it's going to be in reference to already the game object's AI movement script already. But of course, this is conditional. But we just have to do it this way. So what we do now is we reference this AI, right? And we now say is alive. So now we're going to pass down the Boolean false. So now that on the condition that John does get hit, he's not going to ascend to the heavens. He's just going to fall to the ground. So right here, right? So this is going to stop. It's going to put the brake pedals down and John's just going to fall. So let's actually, attach that now. Let me make sure everything's good here. I think so. All right, let's close this. I'll come back to y'all when this compiles. Let's see. Let me count to 10 seconds. Oh, see? Okay. Wasn't that bad. So entity, right, it's going to get the component of AI, and it's going to pass down the value of false on the condition if John does get hit, right? So let's actually ensure that this script is attached. So I have entity and AI movement, these components working in relation to each other. So now that when I do run this, let's see what happens. Let's see if John goes to the heavens or not. And John is just on the ground. This is good, right? So this is just my implementation. It's just a simple way to kind of implement this AI movement and ensuring that, the game object in which it does get hit actually doesn't, continue to, move. So that's it for me. And thanks for watching.